The iodine number is the only calculation for the lipids topic. The iodine number can be defined as the number of grams of iodine that react with 100 grams fat. Iodine, I2, reacts with C-to-C double bonds of unsaturated fats, just like addition reactions, just like the bromination reaction from organic chemistry. So you will always react 1 mole of iodine, I2, per every 1 mole of C-to-C bonds. The general mechanism is really simple. It's just like any other addition reaction. You've got the alkynyl group. You're going to add iodine to that, and afterwards the iodine will have added to the double bond. Now there'll be a single bond, and you'll have an iodine sticking off of each carbon atom. So it's just like bromination. It could be called iodination. Saturated fats have iodine numbers of 0 because they have 0 carbon-to-carbon double bonds. Therefore, they react with 0 iodine. In practice, it's often carried out as a back titration, meaning that you react the fat with a known amount of excess iodine solution. That is allowed to react completely, and then you use sodium thiosulfate to react with the excess iodine. I think that formula is wrong. I need to add a little too. There we go. And once you've done that, you can subtract the excess moles from the total moles of iodine, convert it to the moles that was reacted, and the moles of iodine is the same as the number of moles of carbon-to-carbon double bonds in the fat. And that can also be converted to iodine using molar masses. These problems, I guess, could involve solutions. It's pretty rare, but you would then just use N equals CV to get your moles of either iodine or fats. Okay, in terms of actual calculations, there's really 2 ways that these problems are given. Sometimes you're given the iodine number, and you determine the number of carbon-to-carbon double bonds in the fatty acid. So if you're given the iodine number, 2 times the molar mass of I. The molar masses of fats are either given to you as a MR value, a relative molecular mass value, or they are listed in table 34 here. These are their formulas. So with a little math, you could figure out their molar masses. And if you divide the moles of iodine by the moles of fat, you should end up with a whole number as your answer, which is the number of C-to-C bonds per fat molecule. So this would be an example. It says determine the iodine number of a fatty acid, MR 278. That's the molar mass is 274. Determine the number of carbon-to-carbon double bonds in the fatty acid. So to do this, I'd want to convert both values to moles. So I would divide 274 by, let's see, 250. It's essentially 254 grams per mole for iodine. And I would divide the 100 grams of fat by the molar mass that was given to me, 278. From here, I would end up with moles of iodine on the top, and I would have moles of fats on the bottom, and I would divide the two, and I would get a whole number. And whatever that whole number is the number of C-to-C double bonds in the fatty acid. So this right here, once you've actually done the division. So the first step, right, was divide by molar masses, both the iodine amount and the fat amount. Get moles of each, divide the moles amounts to get a whole number, which is the number of fatty acids. Forgive me, without a calculator, I'm not going to do the calculations right now. The other way is that you're given the number of C-to-C double bonds and you need to determine the iodine number. So if you get that, you should set up a ratio where you enter the number of C-to-C double bonds on top per 1 mole of fat, and then you're going to go backwards, convert both mole amounts into gram amounts, and then really after you divide that, multiply by 100 to get the iodine number, since it's per 100 grams of fat. So a practice problem would be determine the iodine number of linoleic acid, molecular mass of 280. Now, if you're here, linoleic acid is in the data booklet, and from this given formula, you should be able to see that there are 2, right, I probably shouldn't have erased that or covered it up. There are 2 carbon-to-carbon double bonds. This thing in parentheses is repeated twice. So start off with a ratio. The fact that it has 2 C-to-C bonds, you should be able to set up this ratio if you know about the iodine number, that 2 moles of iodine will react with 1 mole of a fat. And now you need to go to grams. So now we're timesing by molar masses. So times 254 on the top and times 280 on the bottom, because we were given that as the molar mass. So then you're going to have gram amounts. On the top, you'd have 508, and on the bottom, you'd have 280. When you divide that, it's going to give you the grams of iodine per 1 gram of fat. So you need to take this ratio and times it by 100, because that will give you the grams of iodine per 100 grams of fat, which is the iodine number. And that will be your final answer. And that's iodine number. There's 2 ways to count, 2 types of problems that you get, and it's really just 2 times of a molar mass conversion and just understanding how the ratio works.